Welcome to Quid Pros Quo, where creativity meets academia. Here, we're all about leveraging our love of academia to improve both your creative writing practice and ours. Whether you're honing your craft or just beginning your writing journey, we're here to share scholarly insights, inspiration, and advice that benefits us all. Let's get started. Hi, welcome to Quid Pros Quo. I'm Rin.
And I'm Zach.
And today we are continuing our Planetary Science for World Building course. And today our topic is stars and galaxies. Zach, do you want to do a recap of our last couple episodes?
Yeah, so to start off our planetary science series, we started talking about planetary systems. We talked about satellites, including moons and rings. And something that we are implementing inside of these new courses is we're assigning homework at the end of each of the episodes. And the purpose of that homework is to get you thinking and to get you incorporating the things that we talk about on the show. And we would love to see what you come up with as a result. And we'd love to read it on the show. So if you have been following along with the podcast and have been doing some of these homework assignments, please send them in to quidprosquo@gmail.com, and we would love to read them on the show. In this episode, I realized that the name of the series is Planetary Science for World Building. We are expanding our view to galactic cosmology. So we're kind of stretching the boundaries of the name for this course, but it will still be super duper fun.
It's almost just astrophysics for world building, because we also talked about satellites, which are technically not planetary science, I feel like.
Yeah, they usually get wrapped up in there.
Okay. Fair enough.
At least as far as the journals and the conferences are concerned. But for what it's worth, brown dwarfs are also wrapped up inside of planetary science, even though they're not planets. But that's a whole other thing.
That's a whole other can of worms. We don't have time for that tonight.
That's so niche.
Or this morning when the episode goes up.
Yep.
Tonight when we're recording. This morning when the episode goes up. Okay. There are two major types of galaxies: elliptical, which are round and old, and spiral, which are just being young. And the Milky Way, our galaxy, is a spiral galaxy.
Yes.
And most of habitability research is in these spiral galaxies. And one reason has to do with the amount of metals we expect to find in elliptical galaxies. The fact that they're old means they don't have many metals, and that you need metals to build planets, including gas giants. Zach, why don't these older galaxies, these elliptical galaxies, have any metals?
Okay.
Any metals?
Yes, this is a good question. So I'm actually going to, so that you can follow along inside of the notes, I'm going to jump down a little bit.
Okay.
Elliptical galaxies are basically blobs. Like they could be kind of like football shaped or kind of globe shaped, but that's kind of the extent of what the structure that we get inside of elliptical galaxies. So once all of the gas and dust inside of that galaxy collapses into stars and then blows up, you don't really get a lot of recycling inside of elliptical galaxies. It's not my field of expertise, but galaxies undergo what is called quenching. And what quenching is a process by which galaxies stop forming new stars. And elliptical galaxies are usually pretty thoroughly quenched. And in order to get a lot of metals, you need a couple of generations of stars. And if you don't have all of those generations of stars, you don't get those metals. So because elliptical galaxies don't generate a whole bunch of new stars from the old material, you don't get the building blocks for the planets where we would set our stories.
Okay, that makes sense. Star systems in I can't talk. Okay, here we go. Star systems in elliptical galaxies tend to be closer than those in habitable parts of spiral galaxies. This is important because when systems are too close together, it can upset the architecture of the system and make life less likely. Elliptical galaxies are mostly composed of low-mass stars, and we kind of explained why this matters with like the metals and stuff.
Yep.
And just in general, elliptical galaxies are not the most common. Like, you're more likely to see spiral galaxies.
Yeah. There is a third type of galaxy, which we're not going to talk about a whole ton, which is called a lenticular galaxy, and it looks somewhere in between the two, but they're more disky, so we're just going to put those off to the side. Yeah. Earlier, I said that elliptical galaxies don't have a ton of structure. Really, the most important thing inside of an elliptical galaxy's structure is concerned is the supermassive black hole at the center. If you don't know what a black hole is, a black hole is basically a mass that has been compacted down into such a small point that its density is high enough that it creates a region where you would have to be moving faster than the speed of light to be able to escape from the gravitational pull of that mass. So, because it's related to the density, you can have black holes of lots of different masses. You can have really small black holes, like the kinds that are created inside of particle colliders and then just kind of poof, go away. And then you can have supermassive black holes. And when I say supermassive black holes, you may be like, well, Zach, how big is supermassive? Because, we're talking about space, and I hear that everything is about zeros. And you're right. When we're talking about supermassive black holes, we are talking about on the order of hundreds of thousands of solar masses. So what that means is if you took the amount of stuff inside of 100,000 suns and then compressed it down into a point smaller than an atom, that's what a supermassive black hole is.
That is? Wow, I didn't realize that's how small black holes were, that they were smaller than an atom. I guess that's a relative thing. That's a relative thing that you're saying.
Yeah, they're... again, this is outside of my field of research, so it's not like I'm an expert. But there are a lot of models that assume that the mass inside of black holes doesn't actually have a volume, which means that it's like all the way down to a single point. So it's smaller than even a nucleus. So like all of that mass compacted down into something that has zero volume.
Okay, interesting. I didn't realize this how they worked. That's very cool. I'm learning fun things today. I always learn fun things on our planetary science episodes. I feel like every time it's like, wow, I learned something new today. Let's talk about spiral galaxy structures compared to elliptical galaxy structures, which Zach just talked about. So, in the middle of a spiral galaxy, you have a bulge, which is like a mini version of an elliptical galaxy, and this is where the supermassive black hole is for a spiral galaxy.
Mm-hmm.
Then you have the halo. This is a diffuse sphere around the bulge and stars moving in all different directions. Because they don't orbit the same way as other stars, they have higher velocities with respect to other stars. So basically, they're moving a lot faster than an average star.
Yes, because everything in space is relative as far as motion is concerned and your speeds. So the way to think about this is that when you're driving on the freeway and you're on one side of the freeway, everybody's moving like in the same direction. So if you were to, like, if you had your little speedometer or like the radar gun and you're like checking out the velocities of everybody around you, they would be super slow because you're not moving, or you're not moving much with respect to each other, right? But then if you point the radar gun at the cars that are in oncoming traffic, those are going to have really high velocities because you're going in different directions. And that's the same thing that's happening with these stars inside of the halo, is that they move in different directions than the stars inside of the disk, which is the next portion of, or the next little piece of structure that we're going to talk about.
Yeah, that makes sense. I guess I forgot my basic physics, that velocity, speed, and direction, and those are both important components of velocity. This is what happens when you don't take a physics class until like sophomore year of college, and then you don't take another one ever.
Yes.
I guess I took physics in like middle school. Like I took a physics unit in my general science class. Anyways, I'm not a physics person. Not me. Anyways, the next part of the structure of the spiral galaxy is a disk, which is divided into the thin disk and the thick disk. This is where most of the stars as well as gas and dust orbit. The thin disk has more metals. Remember that to astronomers, metals are everything heavier than helium, so anything with an atomic number of 3 or higher.
Right.
And the thin disk has more metals than the thick disk.
Yep.
Some stars also have polar rings that are perpendicular to the main galactic disk, and this was what Zach researched before he moved over to brown dwarfs, which is his new specialty.
Yes.
Do you want to expand on that? We might have time for that.
Yeah, so you'll remember when we were doing our episode on planetary systems, right? We talked about how there are theorized to be what are called circumbinary polar rings, where you have a binary star system that's spinning around, and because of the way that the physics works, you can have a ring that's perpendicular to the axis of rotation. I definitely butchered that. So if you're taking a physics class, you're going to have to like rework what I said based off of like where the vectors are pointing and everything. But for our lay audience, what it means is that if you have the stars orbiting in the x-axis, then the ring is in the y-axis. Something similar can happen with galaxies, not just spiral galaxies, but I think those are the more spectacular cases, where because of the way that matter, including dark matter, is distributed around the galaxy, it can mean that there are stable orbits that are perpendicular to the main disk. And that's how you get polar rings, where you have smaller collections of gas and dust and stars that are moving in an orbit around the bulge.
So if the polar rings are perpendicular to the main galactic disk, does that mean most things orbit in parallel with the main disk?
Yeah, so
okay.
It's like everything. It's like if you're on a roller rink, right? And everybody is going around in the same direction. And then you have like weird ghost birds that are like dive bombing and then going through the roller rink and like flying up on the other side. That's how polar rings work.
That was a wonderful example. I love that. That was so funny.
That was a lot better than the merry-go-round example and the yo-yo. That was a dumb example.
Well, we figured it out. I think we got it. We got it eventually. Let's talk about spiral galaxies having more metals because of their structure, which makes them better for planets. So the spirals are most likely regions of increased density, which aids in star formation and gets us more of the metals we like. In essence, the metals that are more important to life and sustaining life.
Yes.
But the increased density can cause problems.
So when you look at a spiral galaxy and you have all of you have the arms, those are the regions that are super bright that look really blue inside of those pictures that you see on the internet. We think that those arms are regions of increased density. When you have increased density, it means that the stars are closer together, which is more like what you have happening in elliptical galaxies, which is a problem because it means that stars can pull on each other and they can pull their planets out of alignment so that they fall into the host star, they get thrown out into space. And then if you have stars going supernova, then they're too close and the planet blows up or just melts because it's absorbing too much energy, which would make it difficult to have life if you melt a planet.
Yeah, melting planets are not a safe habitat for humans or any life.
Yes. This is a really good moment for me to just point out that as an astronomer, I am terrified of space. Like, space is deeply, deeply scary to me. Even though I study it professionally. And the reason why is because of the number of ways that it can kill you, where it's like most of the universe is like so hostile and Earth is not, and that's kind of a miracle.
Yeah, that's so fascinating. But I would argue that a lot of people study things that scare them. Like, I think of like epidemiologists, I think is the word, like people who study
Ooh, yes.
diseases. Like,
Yes.
they may think it's cool, but I'm sure they're also terrified of the like so many diseases they're studying. And like,
Or like
yeah,
microbiologists and foodborne illness.
yeah, exactly. So if you study something scary, you're cool. We don't make the rules. Oh
You
my
heard it here
goodness.
first.
Um, But when you're in between the arms of the spiral galaxy, you have low density metals, which is what we want. That's saying low density and the presence of metals, not low density and low metals.
Yes, low density, presence of metals. We can make our planets and we can put life there and it can be happy.
So cool. However, even though life can be happy, it is not always happy. Just because life can potentially happen doesn't mean it will.
Yep.
Because it can't be too close, otherwise to the center of the galaxy, because the radiation from the center, which is more elliptical, will damage the life. It can't be too far, or the star will orbit the galactic so than the arms do. The spiral arms do. So this means there's a galactic habitable zone. And you'll remember in our other episode on what was it called?
The planetary systems
It's the
episode.
planetary systems episode. Okay. You'll remember that in the planetary systems episode, we talked about the habitable range around a star. This is similar, but it's for a whole galaxy.
Yeah. They're actually, when I was doing some research, when I was doing the research for this episode, I found lots of references to different kinds of habitable zones. So this is just one of them. And it turns out that you can actually break down habitability based off of lots of different criteria. Like you can focus on the presence of water, but you can also look at different kinds of radiation, which is also really important. Just to kind of explain a little bit more about why, you can't be too far out. The way to think about this is that the arms are moving at a different speed than the stars, which is kind of weird to think about, but just remember that it's kind of like cars in traffic. I just spent like an hour on the freeway, so I'm thinking a lot about traffic. But if you're in a helicopter looking down on a freeway, there may be like a big clump of cars, and the clump itself is moving really slowly along the freeway, but the individual cars inside of it may be moving faster than what the clump is doing in there. Okay. And that's a similar thing that happens inside of galaxies, but it's dependent on how far away you are from the how far away you are from the center. So what you don't want to have happen is you don't want to be one of those cars that gets too far ahead of your, of the clump that's right behind you. Because if you get too far ahead, you're going to run into another clump, and it's not great for life there. But you also don't want to be too far out, because if you're too far out, you may fall back into another clump, which would be bad. So you have to be somewhere in the middle where you're fast enough to just be ahead of that wave of density, but not so far ahead that you're running into the next wave of density in front of you.
What else is in galaxies besides stars and planets? Besides also the supermassive black holes near the center, some galaxies are called active galactic nuclei.
Isn't that a fun word?
That is such a fun phrase. Like, it was a bit of a tongue twister. I looked at it. I'm like, okay, I know how to say this, and then I said it, and it did not come out right. So active galactic nuclei, which is when there's gas actively falling on a black hole, which the friction of the gas rubbing against itself will heat up and generate magnetic fields to shoot the material off, and these twin jets of super energetic material, which is so cool, guys.
Yeah,
that's awesome.
It is really cool. Actually, we're hitting on basically all of my prior research today, because this was actually what my first research group was studying, was active galactic nuclei called blazars and how their luminosity varied with time, which super interesting. I won't talk about it very much because it was a long time ago.
Even jets from far away can have an impact on life. So some scientists believe that the burst of light, like those originating from active galactic nuclei, have caused mass extinctions in Earth's distant past. Is that like what we think like maybe killed the dinosaurs? Is that like
It's
when the
not the
mass extinction
dinosaurs, it's
events?
actually older than the dinosaurs.
Oh, very cool. Very cool. You can find star forming regions. Clouds of gas and dust are coalescing into new stars and planets. These will turn into protoplanetary disks, where you'll find lots of asteroids, comets, and planetesimals. What is a planetesimal?
A planetesimal is like what's going to become a planet. It's like
Okay, so it's like the planet's core, the baby planet.
yeah, it's like the stuff that's going to get swept up to make a big planet. So when you think about, I mean, we've all seen the scene in Star Wars where they're going through into the asteroid field, right?
Yeah.
Those kinds of asteroid fields are most likely going to be found inside of protoplanetary disks because that's when you have a whole bunch of material that's accreting onto itself so that it gets like it's close enough together. Because if you were to go out into the asteroid belt in like our solar system, you would like find an asteroid and you would be like completely like you'd look around and you'd be like, where's the next asteroid? And it would be so far away.
Yeah, that makes sense. Oh, that's cool. I didn't know that. That like puts some world building in perspective. Like if you're gonna have a bunch of asteroid belts in your space sci-fi, they better not. They either better be on the same protoplanetary disk, or they better be spread out a lot. I'm guessing. I think those are your two options.
You can always fudge it, but it's something to keep in
course.
mind.
Depending on how hard your sci-fi is, which is this is like a series that's aimed towards helping you make your sci-fi harder. I feel like, but you don't have to. It's not aimed at making your sci-fi harder. It's aimed at making your sci-fi cooler.
Yes, we're providing tools. So if you want to do something, if you want to do hard sci-fi, you can use these tools to do that. But if you also just want to play and be like, oh, this is really interesting. There are lots of things in astronomy where you're like, I would have never even imagined that was an actual thing that existed out there inside of the universe.
Yeah.
And it turns out there are a lot of those. And you just keep digging and you find more and more things. And you're like, whoa, the universe is a lot cooler and deadlier than I ever thought.
I love the and deadlier. You got really like serious for that. And now you're like, it's so much cooler and deadlier than we ever could imagine. Okay. You'll also find star clusters, groups of stars that all form from the same cloud, or stellar remnants, white dwarfs, planetary nebulae, and the leftovers of supernovae. And rarely you'll find objects that have been ejected from their solar systems, like asteroids, comets, and sometimes entire planets. I'm not going to say that right. You can say it.
Yes. So you'll remember a few years ago that there was a lot of hubbub about Oumuamua. That's how you pronounce it.
Okay, excellent. I know exactly what it's talking about. I just like looked at it and I was like, there's no way I'm saying that right.
Yeah, it's Oumuamua. It was the thing that came into the solar system, flew by the sun, and then exited the solar system. It's the first thing that we've observed that came from outside of the solar system. And a lot of people thought it was aliens.
That's true. A lot of people did think it was aliens. I think that was like my senior year of high school. It was like 2018-ish, right?
Yeah, somewhere around there.
And I remember watching a CNN clip on it.
Mm.
Like, I have this very distinct memory of that. And I could not tell you what the CNN clip said about it. Okay, anyways. Galaxies can collide. Zach, talk to us about this.
Yes. Okay. So galaxies can collide. In fact, the Milky Way is currently on a collision course with the Andromeda Galaxy. So sometime in the future, they're gonna collide. But when I say collide, don't think about a car crash because it's not like a car crash. It's more like an oil spill. And I think thinking about it like an oil spill is actually really helpful because what happens is that the gas, the dust, the stars are disturbed from their orbits and they all get kind of thrown out all over the place. And so for a little bit, you'll have these kind of weird and wonderful, shapes where it's a lot more interesting than just discs and lines and belts and that kind of thing. It'll actually be like wavy and sharp and stuff. There are animations of what these mergers look like that you can find on YouTube or
I was
spots
like,
around the
I'm
internet.
like resisting the urge to go look it up right now, just so you know, because I know my keyboard will be audible on the recording.
Yes.
Okay.
The other reason why you shouldn't think about them like car crashes is because planets and stars are very unlikely to run into each other. Like, I'm not saying that it would never happen, because in astronomy, words like always and never are really bad ideas.
Only a Sith deals in absolutes.
Exactly. And astronomers are not Sith. But you can end up with cases where stars get too close together and they, disturb things so that, maybe you throw two planets, into each other and they blow up, or you throw a planet into the sun and then it, is incinerated, or you rip the planet out of its system and it gets thrown off into the cold, dark reaches of space. You could also get some too close to something that is going supernova or is doing some other kind of weird, wacky thing that makes it so that you don't have life on the planet. So merging processes are dangerous to life, but they take place over the course of millions and billions of years. This is not something that, a person would see happening. We're talking eons of time, where it's like the dinosaurs would see part of it and then the humans would see another part of it, and then 200 million years into the future they would be seeing something else, whatever is there.
Very cool. Galaxies can also clump together, which is a way broader topic. But let's just mention that some galaxies, like the Milky Way, are orbited by dwarf galaxies, kind of also like in Star Wars.
Yes, so there's a dwarf galaxy called the Rishi Maze in the Star Wars galaxy, and the Milky Way has two dwarf galaxies that orbit it. And I think with that, I'm going to transition into talking about how authors can use this research in their writing and their world building, because these orbiting dwarf galaxies can be really interesting things to play with, because they have separate formation histories from the host galaxy. So you could have it be that those are like separate administrative zones or empires from whatever else is in your galaxy. Or if you're a sucker for ancient civilizations like I am, you might have the ruins of species that used to live inside of those dwarf galaxies before they came to orbit the host galaxy. Those are two options for how you could use those dwarf galaxies, and there are many, many more.
Very cool. In general, let's talk more about how authors can use this research in their writing world. First off, your planet's probably in a spiral galaxy. It just makes sense statistically, which means the night sky has a band of stars and dust like our own. If your planet is in a galaxy undergoing a merger, like a collision of galaxies, the band of stars may be more curly or wavy, which is a cool visual to think about.
Yeah.
However, your planet could be orbiting slightly above or below the disk of the galaxy, which would make more of the disk visible in the night sky. It could even be in a polar ring, so you can see the entire galactic disk in the night sky, which would be so sick.
Yeah. That would be so cool.
Imagine if we were in a polar ring and we could see the entire Milky Way disk every night.
One of the guys inside of my PhD program would really love that, because his entire research is about, or at least one of the research projects that I worked with him on, is about trying to get a better handle on what the structure of the Milky Way is, because it's really hard to find out because we're looking at it from the edge.
Yeah, that's rough, buddy. I don't know what to say to that. For interstellar travel, most of your habitable planets will be in a ring around the galaxy rather than distributed evenly from the center to the rim. So not Star Wars in this case.
No.
Opposite of Star Wars.
Yeah. I will say that at least in the expanded universe, many moons ago, they authors were really good to point out that you couldn't go into the deep core because there was too much radiation. So they got that aspect of the science correct.
Okay, very cool. Good for them. Proud of them.
Yeah.
But the ring around the galaxy where your interstellar travel is happening is going to be broken up depending on the number of arms and how tightly wound they are. These breaks can be natural borders for administrative zones in a galactic community or separate interstellar empires. Because if you have a few rings that are pretty spread out, it's going to make a lot more sense to have like maybe one empire per arm.
Yeah.
It's harder to travel in between the arms if they're bigger and more spread out.
Mm-hmm.
But if they're really close together, then like maybe it's one empire and a bunch of different administrative zones. I'm watching Andor for the first time right now, and I'm loving like the political intrigue and the political drama of the like they're over all these sectors. Yeah, I know. I've been meaning to watch it for literally years. I'm just so bad at watching television. Like so bad at it. But I just started sewing a new like outfit, like a new project, and I'm like I put my iPad in the corner of my desk, which I have a tiny desk, and my sewing machine is behind my screen on my desk. Anyways, it's very crowded right now. But I just started watching it, and the iPad sits in the corner of my desk, and I watch Andor while I sew, and I'm like 6 or 7 episodes in. Like it's taking a while. Anyways, fun stuff. Zach, do you want to take our next bullet point?
Yes. This is actually the last bullet point, now that I think that I'm looking at it.
But, through the rings?
Yeah. Because we already talked about dwarf galaxies at the top.
Oh, we did. You're right.
So, traveling through the rings can be dangerous due to increased density. But also when you're traveling through those denser portions, you're going to run into all of those fun things that we talked about earlier. You know, you're going to run into those star-forming regions. You're going to run into those those stellar remnants. You're going to run into all of those fun things. You might even find a black hole in there, because black holes can be found not just in the center of galaxies. You can find them in a lot of different places.
So we are getting to the end of our planetary science series. We will have 2 case studies, an indie book and a trad published book, and we will go over how they apply planetary science in their world building. But this is just the beginning. Zach's newsletter is all about explaining how authors can use cutting-edge scientific research to inform their world building. If you're interested, head on over to DC Winters, that's Winters with a Y, dcwinters.substack.com to check it out.
And now let's talk about homework. So, for the homework, first thing that you're going to do is choose whether you are dealing with a galaxy that is going under a merger or is not. And then you're going to choose how much of the galactic disk your world can see. After you do that, you'll come up with a couple of different names for what that is inside of the sky. Like, we call it the Milky Way, but we could have called it something else. Come up with something else that your world may have called this thing. That the cultures would have called the galactic disk inside of the sky. And then pick 1 or 2 and come up with a short myth related to that name and share it in the comments or send it to our email at quidprosquo@gmail.com, because we would love to share it. We'd love to read it and appreciate your creativity.
Please send us your homework. We want to see all the cool things you're coming up with. It would be so fun for all of us. Please just send us your homework.
Yes.
Perfect. Well, this has been Quid Pros Quo. Next week we'll be starting our case studies for planetary science. And then we'll be moving on to a different course, which I believe Fairy Tales is the next course, which means I actually have to finish the book on the Grimm brothers that I picked up and have not finished yet. I'm like 20 pages in, and it's like 300 pages.
Yep, after this is Fairy Tales.
Cool. Time to get reading, and guys, don't forget your homework. Thank you so much. This has been Quid Pros Quo.
Quid Pros Quo is hosted by DC Winters and CK Jensen. If you like this episode, please subscribe and leave us a rating on Spotify, Apple Podcasts, or wherever you get your podcasts. If you'd like to contact us, you can email us at quidprosquo@gmail.com. Thank you for joining us today.